Hey guys, so today we're going to be looking at modeling annuities on Excel. Because since now you guys have learned how to calculate these annuities by hand, we're going to learn how to do them using Microsoft Excel, which is way easier than doing it by hand, and quite frankly, way more enjoyable. So if you've never seen or used Microsoft Excel, um, I'm gonna try and make this as user friendly as possible for beginners. And yeah, this is how an Excel spreadsheet looks like for the first time. So welcome to technology and the new world where we're not calculating by pen and hand anymore. We're using computers. Okay, cool. So how we're gonna do this is we're gonna use examples for each type of annuity, and I'm gonna model that type of annuity whilst explaining, and you can kind of see and get a feel for how to do the different types of annuities and how we'll apply them in financial mathematics. Okay, so the first example, find the present value at 10% per annum effective of an annuity certain of 100 Rand per annum, payable half yearly in advance for 10 years. So this is an example of an annual annuity payable monthly. In this case, P is 2 because it's payable half yearly. So in FinMath, in general, when you're given these types of questions, you're going to want to note down your important information. And I generally like to note it on this side of the Excel spreadsheet because I'll have my formulae and table and whatnot on this side. And so when I'll need to reference a cell with the information, it's easier to know that all the information is this side. So I can reference it here. I can reference it from here. But yeah, just use what works for you. But I'm going to note the information on this side. So I'm going to start by taking down all the necessary information. So we want the present value at 10% per annum effective. So that's the first piece of information. I is equal to 10%. And because there's different types of interest rates, as you guys have learned, we need to note down the type of interest rate that this is. And this is an annual effective interest rate. So per annum, and this is effective. Usually when they say per annum, you can assume it's effective if they haven't said like convertible monthly or something like that. But I'm just gonna write per annum effective for accuracy purposes. So it's an annuity certain of 100 Rand per annum, payable half yearly in advance for 10 years. So I'm gonna write down the term first because that's the easier part of the that chunk of information to note down. So the term is 10 years. By the way, I'm putting the numbers separate, like I'm separating the numbers and the words, like 10% and per annum, 10 in years. Because when I reference a cell and the cell has 10 years, I can't use this cell. I can't use this cell in a calculation because this is a combination of, it's a string, and it won't interpret, the formula won't interpret it as a value. So that's why I'm writing years in different cells like this. So the amount payable, the amount that you get per annum, so the payment is 100 Rand per annum. Okay, 100 Rand per annum. But the frequency of this payment, because it's payable half yearly, we pay it 2 times per year. The frequency is 2. So in actual fact, the actual payment that you receive is equal to 100 Rand divided by 2 because you pay 100 Rand in a full year. But this 100 Rand can be payable in 2 payments in that year. So every half year, you can imagine you pay 50 Rands. So 50 Rands per half year. Just to go over that again, in a year, you pay 100 Rand. Okay, in a year, you pay 100 Rand. But this 100 Rand payment is not only payable annually, you don't have to pay it annually. You can pay it half yearly if you want. In other words, you pay a certain amount per half year. We know that there's 2 half years in a year, so the frequency of payments is 2, and the actual payment or the half yearly payment will be the amount that you pay in total divided by the frequency of the half yearly payments, which is 50. Now, another uh, piece of information worth noting is that this annuity is in advance. Okay, it's in advance. Well, I can just put that here per half year in advance, per annum in advance. Okay, so we have our information here, and I'm just gonna highlight it so that it looks nice and it's attractive, it's bright, and it's easy for us to see. So just gonna adjust the size of the cells by going, you go to the border of the column of the cell here, and then when it turns from this drop down arrow to this thing, you just double click and it'll adjust the size of the cell according to the stuff that's in the cell. Yeah. What else? What else? What else? And okay. So now we get to actually modeling the annuity. Um, Something that I used to do when I first started learning Excel, which was very bad, is that since I know an annuity formula for this, which is the annual payment times 1 minus 1 plus I to the minus number of years over the Peasley nominal rate, or you can change this into a half yearly annuity and use a half yearly effective. In order to calculate this annuity, I would how I would do it would be is equal to 100 Rand times, okay, I'm gonna put brackets. So 100 Rand times 1 minus 1 plus the annual effective interest rate, which is this cell, to the power of minus the term in years, which is 10 years, all over the nominal effective rate. In this case, the half yearly nominal, so 2 times 1 plus I, which is 10%, to the power of minus uh, 1 over 2, because P is 2 minus 1. Oh my goodness, I made a mistake somewhere. Um, yep, so I have a minus here instead of a positive, so it's supposed to be to the power of 1 over 2, and that gives us 62945,42. So this is the value of the annuity, and you can get it pretty easily, but this defeats the purpose of Excel because it's the same as calculating it by hand essentially, and we're using Excel to kind of avoid this. Excel makes it gives us a better way, and as you can see, this formula up here is very messy. It's very messy, and it's easy to make a mistake and get the wrong answer. So I'm going to shift this answer. I'm going to put it somewhere here, and we're going to refer back to it later after we've modeled this the right way. Now the right way, we start off similarly to how we'd start off when calculating an annuity by hand, which I always preach to you guys, which is start with a timeline. Start with a timeline. So we're going to start with a timeline, and the equivalent on Excel of a timeline is a time column, and we're going to divide this time column. We're going to take it by increments. Now we're working in half years here. Half years 0.5 years. So we're going to work in increments of 0.5. So you're going to start at the present time times 0. Going to move to the first half year 0.5, second half year 1, 1.5, 2, etc. And there's 10 years. Now Excel is very smart and very considerate of us that if we have a pattern like this, it recognizes the pattern, and you take your cursor down here to the bottom right corner until it goes from this big white cursor, uh, big white thing, to this smaller, more narrower black thing. And then you drag it down, and you can see that it's continuing the trend. And when it gets to 10, that's where I want it to stop. So yeah, it does that really nicely for us. So now we have our timeline. Now that we have our timeline, we can kind of put our payments there, or our cash flows. Now, each half year you pay 50 Rand in advance. So it starts at time 0. I'm not gonna put 50 Rand everywhere here. I'm just gonna write a formula and drag it down. So what that looks like is that I'm gonna say this is equal to, and we already have 50 Rand in our piece of information. This is what I was talking about. We're gonna reference this cell. So is equal to this cell B13, and I'm gonna fix this cell because I want it to keep it constant when I drag the formula down, and I'm gonna show you what that means. So to fix a cell, I'm gonna press FN4 on your laptop, on my laptop, FN and then F4, sorry. Alternatively, you can just put in these dollar signs manually behind the column reference and the cell reference. So that's our 50 right there. And then because um I've already laid out how many cells I want to use or how many rows I want to use, when I go to the next column, it automatically assumes that I want to use the corresponding number of cells. So I don't have to drag this down like I did the other time. Like I don't have to drag this down manually like I did the first time. I can just come here until it's black again and narrow, and then double click and it'll fill out until the 10. That's cool. So this is wrong, by the way, because these payments are in advance, so there won't be a payment in the last half year, like at the end of the last half year. Now, if you count the number of payments, you can see here it says the count is 20. There's 20 payments, and so there's 20 half years in 10 years. So this is correct. If there was a 50 here, then it would be 21, which would make it incorrect. So these is our payment structure. Cool. So now we have our payment structure. Now we need our discounting factors. So what you can imagine we're doing here was we're just populating our timeline. We have the timestamps and we have the payments at each time. Now we need the V factor at each time. And the V factor is the discounting. The discounting factor is equal to 1 plus the interest rate. So 1 plus, and I'm going to reference R. You see, I said it would be useful to put the information on this side, and so it's easier. I know when I want to write down a formula, I just always reference this side. So 1 plus I, and I'm going to fix this interest rate because I don't want it to change. We're always going to be using the same I throughout. So I'm going to press FN, F4. I'm going to put those nice dollar signs there, and then I'm going to raise it to the power of. Now, when you put the discounting factor, when you're at time 0, you have v to the power of 0. When you're at time 1, you have v to the power of 1. When you're at time 1, comma 5, you have v to the power of 1, comma 5. Now, a smart way to do this on Excel, we don't want to do it manually. I'm going to say I'm going to raise it to the corresponding time for that cash flow, for that discounting factor. So this is the discounting factor at time 2, at time 0. The corresponding time, the corresponding time cell is this cell here. I'm not going to fix this because I want it to change when I drag the formula down. So when it's here, I want it to change to to this cell. When it's here, I want it to change to this cell. How I do this is by not fixing it. Press enter there. And this makes sense. 1 plus I to the power of 0 is going to be 1. And then I'm going to double click and it's going to autofill to the power of minus. My apologies. It's supposed to be to the power of minus the time. And yeah, these are my discounting factors. Here it says 1 plus I to the power of this time. At time 0, comma 5, it says 1 plus I to the power of minus 0, comma 5. At time 1, it says 1 plus I to the power of minus 1. At time 2, at time 1.5, it says 1 plus I to the power of minus 1.5. So it carries all of these forward, and that's what we like. So we now have we now have each time, the payments at each time. Oh my goodness. 8. The payments at each time and the discounting factor at each time. Now we can get the present value of each cash flow. What I'm going to do again is I'm not going to fix any cells. I'm going to say, so the present value of each cash flow is that you take the cash flow, I'm going to reference the payment multiplied by the corresponding V factor at that time, for that cash flow. In this case, the V factor is 1. So I'm going to say the payment times 1. I'm not going to fix any of these cells because I want Excel to drag this down. So at time 0, comma 5, it's going to use the corresponding payments for 0, comma 5 and the discounting factor. Same with 1, same with 1, comma 5. And then to get the net present value or the value of the annuity, you just simply sum all of these numbers. And there's an Excel function called sum, which you can use to sum objects. So I'm going to sum all of these numbers in this column, and it's going to give us the answer. I should say, um, what is this? And we get the net present value as 660,175. And this doesn't quite match up with our formula here because I mistakenly used the formula for an annuity in arrears, for a Peatley annuity in arrears instead of in advance. So this is supposed to be 1 minus this to the minus 1 over 2 because it's the Peatley discount factor, and you can see now that they match up. So my bad there. I hope you guys caught that mistake. Now, alternatively, instead of multiplying these columns manually, like instead of multiplying the payments by the discounting factor manually to get the PV at each time and then summing them, what you could do, I'm going to put or here, is that you can use this Excel function called sum product. And sum product takes arrays as argument. So the first array is going to be this column of payments. The second array is going to be this column of discounting factors, and it's going to give you that answer. So what it does is that since I've entered two arrays, it's going to say the first object in the first array times the first object in the second array plus. So it takes this product and then takes the sum. So plus the second object in the first array times the second object in the second array plus, and then it does that for all of them. So it takes the product of the corresponding objects and then sums them. So yeah, the cool thing about Excel, unlike a formula, is that it allows you to see the cash flow structure. It allows you to see that, the payments, in this example, the payments are the same throughout, but the present value of the payments, as you go further out in time, you can see what our principles that we learned in fin math, that the further out in time you are, the more that the cash flow is discounted. You can see that it goes from being 50 to being 20. So it's discounted more the further out in time it is, and we can see which cash flows contribute more, particularly these ones. They contribute more than the latter ones, which are just in the low 20s. So Excel allows you to make these types of analysis. That's why we like it. Of course, this is a very basic example. We're gonna get to more interesting examples as you guys master Excel. So this is a present value annuity certain, payable half yearly in advance. If it was payable quarterly, all that would happen is that you just change the timestamps, the time increment. So you'd have 0, 0.25, because that's a quarter of a year, 0.25 of a year, 0.5, 0.75, and 1. And you divide the year accordingly. If it was monthly, you'd have 1 over 12, 2 over 12, etc. But since we're dealing with half yearly here, we've divided by 0.5, etc. And another thing is that if these payments were payable in arrears instead of in advance, so if we had in arrears here, in arrears, put in areas here, all that would happen is that the first payment would happen at time 0.5, so not at time 0, and would have a last payment here at time 50. So, and this again matches up with our principles that we've learned. You can see that if it's in arrears, it's considerably less than if it's in advance, because in arrears, on average, it occurs later in time because we have one last payment in time 10 and no payment here. So on average, it's discounted more, and so it'll be less than in advance. So yeah, that's an annuity certain, payable half yearly in advance for 10 years. Moving on to the next example. Uh, it's the same thing that I've written down, so the information is the same, but I want us to do this example, or this same example, but for a future value annuity now. So since the information is the same, I can just be lazy and copy it down. So we're gonna copy down the information and we're gonna put it in exactly the same place. Put it in exactly the same place. And so, yeah, this is still in advance from the initial example. In advance. And so we're now going to have a future value annuity. I want you to ignore present value and we're going to use future value. Now we're still going to have our timeline. So we'll have our time column here as follows, from time 0 up until time 10, going in increments of 0.5. And we still have our payment structures here. It's in advance, so the first payment will start at time 0. I'm not going to reference a cell here. I'm just going to write 50, and Excel is going to hopefully be smart and catch my drift and just put down the 50s, which it did. And then here, now, since this is a future value annuity, instead of discounting, we're going to be accumulating. So we won't have discounting factors, we'll have accumulating factors. Now, um, this is a bit different from the discounting factors because it is 1 plus I. It's 1 plus I, and we're going to fix I. So Fn F4 to the power of, and we're going to have a negative power. It's not going to be to the power of T, okay? It's going to be to the power of where you're going, which we want it at time 10. We want the future value of an annuity certain of 100 Rand per annum payable half yearly in advance for 10 years. So we want the future value at time 10. So we're going to say raised to the power of time 10, and we're going to fix time 10 minus the time where you are now. So at time 0. And if you think about it, this makes sense because if a payment is at time 0 and you want to take it to time 10, you say 1 plus I to the power of 10. That's 10 minus 0. You don't say 1 plus I to the power of 0. If a payment is at 0, 0.5 and you want to take it to time 10, you say 1 plus I to the power of 9, 0.5 because that's the distance between time 0, 0.5 and time 10. And that'll be 10 minus 0, 0.5. If you're at time 1, it'll be 1 plus I to the power of 9 because that's the difference between 10 and time 1, which is 10 minus 1. So what this does is that it fixes the interest rate. So to use the same interest for all the cells, it fixes 10. So it's going to subtract the time from 10 each time. And so you're going to have 10 minus, but this one isn't fixed. So it's going to go down with the column. So here it's going to be time 0. Here it's going to use the corresponding time 0, 0.5. Here's going to be the corresponding time 1. And those are our accumulating factors. And it makes sense that if a payment is at time 10 and you want to accumulate it to time 10, it will be 1 plus I to the power of 0. So you just multiply that payment by 1. So just take note of that difference. And then we'll have our accumulated values here, which will just be 50, will just be the payment time the accumulating factor at each time. And the future value will just be the sum of this entire column. And there we have it. Another way we could have done it is like we did in the previous example. You can use sum product where we enter this array as an argument, and then we enter the second array of accumulating factors, and it'll do exactly the same thing as it did before, which is just multiply corresponding elements in each array and then sum all the products. And by the way, it doesn't have to be just one array. It can be two arrays. You can enter a third one here. It's just that here we don't need it. And you can see that these two values match up. So we calculated this correctly. By the way, you guys can check these values by hand. You can calculate this by hand using the formula just to make sure uh, I did that correctly. Okay, we just added borders here using Alt HBA for covering all sides. And yeah, and like we did in the previous example, if this was in arrears instead of in advance, we would have no payment here and a payment here. And again, it's less than the previous one, but this time it's because on average, the values are closer to the time that we're accumulating to. And so on average, they're accumulated less when we're in arrears. And so it'll be less than if it was in advance, or we have the first extra payment in the beginning, where on average, they're further from the time that we're accumulating to, which is 10. And so they will be accumulated more. Cool. That's a good second example. So we've done present value annuity payable piecely, future value annuity payable piecely. Now we get to other examples, more interesting examples. So here we have, I'm going to write down the information here, like I said. Let's just read it first. We have an annuity payable annually in arrears for 20 years. So we're told that the term is 20 years. The first payment is 10,000 and each subsequent payment is 400 less than the preceding one. Find the present value of the annuity on the basis of an interest rate of 10% per annum effective. So the interest rate is 10% per annum and this is effective. But note that in convention, if an interest rate is not described explicitly as effective or nominal, some equivalent wording, it is an effective rate. So that's what I was saying. Into the annuity can be seen as a level of annuity. This is useful when you're calculating by hand, where you can split the annuity into a flat annuity and an increasing annuity. But we're using Excel, so we don't need that here. I deliberately skipped the payment structure just so we can put more emphasis and time on it. It says the first payment. So firstly, this is a decreasing annuity because the first payment is a certain amount and each subsequent payment is 400 less. So a fixed amount less than the previous one or than the preceding one. So it's a decreasing annuity. It's basically the same as an increasing annuity, just the other way around. We model it very similarly on Excel. So we're going to do this example of a decreasing annuity because it's solely because it's the one that I found. So I'm gonna note the first payment is 10,000 and the decrease is going to be 400 per annum. And the payments are made in arrears. So that is our information for this annuity. Okay, cool. Now we're gonna model it. We start again with our timer. So this time we're working in years because the payments are annual, all of them, and the decreases are annual. So we're working in years starting at time 0, 1, up until 20. So I'm just gonna drag this down to 20. And then we're gonna get to our payment structure. There's the tedious way to do this, and there's the lazy man's way to do this. Okay. The tedious way to do this is to write is to type in each of the individual payments. So you'll say 10,000 and then 10,000 minus 400 is 9,600. And then you'll say 9,200 and then you'll do that for all of them. It's any of them. But because, they know XI knows how much you like the easy way out, they'll never give you or they'll rarely give you payments in which you can model them by like doing tedious methods like this. Oh, it doesn't help to be to use this tedious method because sometimes you're given cash flows for a very long time. Let's say monthly cash flows for 20 years and the cash flows are different month on month. You're not going to write all of them down. It's better to have a formula that you can drag down that'll model each payment for you. So what we have here is that the first payment is 10,000. So I'm going to put 10,000 here and I'm going to fix the 10,000. I don't think you have to fix it, but yeah. And then for each payment, I'm going to say the payment before that minus the fixed 400. So I'm going to fix 400. And then I'm going to drag this formula down. What this formula is basically saying, it's saying, okay, for the next payment, take the previous payment and subtract 400. And I deliberately I fixed 400 because I wanted to subtract 400 every time from each payment. So take 1,000, subtract 400. For the second payment or the third payment, take 9,600 and subtract 400. Just realize now that I made a mistake and these payments are in arrears, so they should start 1 year later and there should be no payment there. Okay. So we have 20 payments, 20 years, all in arrears. This makes sense. Okay, cool. Another way to do this is like using this hint where you see it as a 10,400 flat annuity minus an increasing annuity. You could use a formula for, I think it's a linear sequence where you say 10,400, that's your flat annuity. That's your fixed value. I even typed it in as a value so that it doesn't changes. Minus the payment minus the constant difference, which is 400 times the time that you're at. So here it'll be minus 400 times 1. Here it'll be minus 400 times 2. Here it'll be minus 400 times 3. And then it'll give you the exact same payment structure. So, I mean, there's multiple ways to get to the same answer. Just pick your poison. And I like the poison that I picked here. So we're going to go with that poison. Okay, cool. So after this, it's just getting your discounting factors as we did the first couple of times. Your discounting factors will be your V factors at each time. So 1 plus I, and fix I to the power of minus T. And then we're gonna do it both ways. We're gonna get the PV, and then we're gonna say the payment times discounting factor, and then drag that down. And then to get the net present value, we're just gonna take the sum of all of these present values and add them up. Or you can use our friend sum product. And we enter, oh, I forgot my equal signs. Enter the payments, enter the discounting factors. Oh my goodness. What did we do wrong? We have an inequality side here. Should be a comma. And there you go. We have the same answer. I was gonna put this, yeah, we have the same answer. I was gonna put this in the currency. I was debating, but it's fine. Same answer. Just gonna add borders to this. I'm gonna highlight it. So yeah, that's how you get a decreasing annuity. If this was an increase, so let's say instead of decrease, you had increase here, what would change is that you'd have exactly the same formula, but you'd have a plus here. You'd have a plus here, and then that's the formula that I'll drag down. So, oh my goodness. Uh, I'll drag down this formula. Yeah, that makes more sense. So I'll drag down that formula. So that's why I said a decreasing annuity and an increasing annuity, basically more or less the same thing. So yeah, that's how you model an increasing annuity or decreasing annuity in Excel. I'm just gonna revert these changes. So we go back to our original question. I will say this is helpful because when you're evaluating and doing analysis, financial analysis, a formula isn't always the best route because yes, it'll give you a final answer, but it doesn't give you an idea of what's happening in between. Like I emphasized before, here we can see that the first time the cash flow that we're actually receiving at time zero is 9,000, 7,000, 6,000, and then it decreases. You can see the actual values of the present values at each time, and you can do more in-depth financial analysis rather than with a formula where you just get the final answer.